Hello there. Here I have a lesson on adding and subtracting fractions. Now, these fractions are going to have polynomials in them so that we get to look at them as rational expressions instead of just our normal common fractions. But before we get to the fractions with polynomials in them, I want to look at fractions with just constants in them, numbers. And we're going to look at 7/12 minus 11/12. Well, you know and I know that when you add or subtract fractions, you have to have a common denominator. Luckily for us, in this first one, we do have a common denominator, which is 12, which is also going to tell us that our answer, is also going to have a denominator of 12. And now we just get to subtract those numerators. 7 minus 11 is -4. And we always want to have a simplified fraction. So we look at this and go, well, they both have a common factor of 4 in them. We divide that 4 out. The 4 becomes 1. The 12 becomes 3. And I end up with a final answer of -1/3. Now, my second one, I look at it and go, denominators are not identical. I don't have a common denominator, but very close, because the denominator of this one I would look at is just the opposite of the 5 in the second one. Now, some of you will look at this and recognize, well, 3 over a -5, that's the same thing as a -3 over a +5. So we can look at it that way, and then it's plus 4/5. Now we have that common denominator. If we take -3 plus 4, we get 1. Our common denominator is 5, and our final answer is 1/5. Now, another way to look at that is how we get the -3/5. We could look at that as also saying, well, really, we just multiplied this numerator by -1, and we multiplied that denominator by -1. Because really, then, we have multiplied by -1 over -1, which just equals 1, and it doesn't change the fraction. And that's where the -3 over 5 comes from, still plus the original 4/5, and we're at 1/5 that way as well. So a little technique there is to get our negative denominator to become a positive one, so we have a common denominator. And there, again, is just our little review with the fractions, with our real numbers in them, because now we're going to take a look at adding our rational fractions, rational expressions. Notice here, common denominator, so that makes it nice. Our answer is going to have a 15 in the denominator, and now we just have to add our numerators. Well, 4n plus 16n puts us at 20n. Is it a simplified fraction? It is not, therefore we need to simplify it. I notice 20 and 15 both have a common factor of 5 in them. I'm going to divide that factor out. The 20 is going to become 4, 15 is going to become 3, and now I'm left with an answer of 4n over 3. We could also write it as 4/3 n. Either way, we have an acceptable answer. Take your pick as to how you want to display it. Our next one, again, nice that we have a common denominator. So when I go to my answer, I'm going to have f minus 3 in the denominator. And now we have to subtract. Well, when we subtract, we're going to have to subtract like terms. So I'm going to start off, I have 7f. I have to subtract f. And 7f minus f is going to put us at 6f. And then I've got to come back, and now I'm going to look at the 9. I have to subtract a -5. 9 minus a -5 minus a negative tells me to add. So I'm going to end up with a positive 14. Well, can I simplify this at all? I do look at that numerator and notice that I could factor a 2 out of the numerator. And if I factor a 2 out of the numerator, I'm left with, let's get the 2 out of there. I'm left with 3f plus a 7. Denominator is still f minus 3. Is there a common factor in the numerator and denominator that's going to divide out? No. So in this case, it wouldn't matter to me which one you would display your answer as. You could pick. You can pick the one that I ended with, where it's in factored form, or this one where it's multiplied together. Either one would be acceptable. Now I have this one, where it's 3j over the 11 minus j plus the -4j over j minus 11. And I'm hoping that you're recognizing right away that we don't have a common denominator in this one. And if we don't have a common denominator, we have to get one. But what I am hoping that you're recognizing is these denominators are opposites of each other. So I look at this and go, here I have a positive 11, but over here it was negative 11. Here I have a negative j, here I have a positive j. They're just opposites of each other. So if I have that case, it's like that example from the very first slide where I need to get one of those denominators to switch the sign on it. Now for me, I would prefer to have my variable be first and the coefficient of that be positive. So I like this denominator here. I want to get this one to become the same thing. So what I'm going to do is I'm going to use that technique from the first slide where I multiplied my numerator by -1 and my denominator by -1. I'm not going to change the value, I'm just going to change the way it looks. So if I multiply that numerator by -1, I end up with negative 3j. Multiply my denominator by -1, now I have a negative 11 plus j, which some of you are saying, well, it still doesn't look like what I have underlined in red, but I could take this and just switch the order. Maybe. Let's go like this. So I could take the negative 11, bring it over here, take the j, and bring it over here, and now I have j plus a negative 11, so really I could get rid of the plus sign, and I have j minus 11. Just change the order in an addition problem. So then I still have to add on that original plus the negative 4j, can't dot my j, over the j minus 11. I have that common denominator now. So my answer is going to have a denominator of j minus 11. My numerator now I just add, well, negative 3j plus negative 4j would put us at negative 7j. I noticed I can't factor the denominator. The numerator, there's nothing really to factor there. So then my final answer is negative j over j minus 11. Here now, again, I have a common denominator, x plus 2. So my answer is going to have a common denominator, the same denominator of x plus 2. And then again, I'm going to subtract my like terms. 3x minus x is 2x. Negative 1 minus negative 5. So I look at it as negative 1 plus 5, which would put us at plus 4. And then it's just a matter of trying to simplify our fraction. I look at that numerator and I see that it has a factor of 2 in both terms. So I'm going to factor that 2 out. If I factor the 2 out of 2x, I'm left with x. I factor a 2 out of 4, I'm left with 2. My denominator, nothing to factor, x plus 2. But now I notice that I have a common factor of x plus 2 in the numerator and the denominator, so those will divide out. And my final answer to this subtraction problem is just 2. And that's going to conclude my lesson on adding and subtracting rational expressions with like denominators or with common denominators.